2, integrations of trigonometric functions. In this subtopic, we are going to learn how to find the integral of trigonometric functions of sine ax, cosine ax, and cosecant square ax. And we are going to include the integral of constant multiple, sum, and difference involving the trigonometric functions. We also will do the integrations of the sine square ax and the cos square ax. And finally, we also learn how to use the double angles and compound angles formulas to solve the integral of trigonometric functions. To derive the formulas of the integrations of trigonometric functions, so we may use the reverse process of differentiations. So first of all, we start with the differential of the sine x. So we are going to get the cosine x. So therefore, the reverse process. So if we do the integral of the cosine x, so we are going to get the sine x plus the constant c here. So therefore, if we have the function cosine ax plus b, so first of all, if we differentiate the cosine, so we get the sine ax plus b, and further by the divisions of the differential of the ax plus b, so which will give you a, so you're going to divide by a here and plus the constant c. Furthermore, if we have the differential of the cosine x, we get the minus sine x. So therefore, the integral of sine x, so we are going to get the function of the minus cosine x plus the constant c. So therefore, so to integrate the sine ax plus b, first of all, so if we integrate sine, so we are going to get the functions cosine and plus the divisions of the constant that you get from the differential of ax plus b here. So therefore, we are going to have the minus cosine ax plus b divided by a followed by the constant c. Okay, finally, the differential of the tangent. So we are going to get the secant square x. So therefore, the integral of the secant square x, we are going to get the tangent x plus the c. So therefore, if we have the secant square ax plus b, so when we want to integrate this, so we know that the integral of secant square, you will get the function tangent. So that's why we are going to have the tangent ax plus b divided by a. So whereby a is the differential of ax plus b. So this is how we derive the integrals of trigonometric functions. Okay, let me explain to you through the following examples. So we're going to find the indefinite integrals of the following functions. So A, so we're going to find the indefinite integral of the function sine 2x. So as we know from the formulas, the integrals of the function sine, so we are going to get the negative cosine plus the angle, and the differential of the angle 2x, so we are going to get the value of 2. So therefore, for the indefinite integral of sine 2x, so we are going to get the minus 1 over 2 cos 2x plus the constant c. Okay, so the second B example, so we have the function 3 cos 4x minus pi over 2. Okay, so we just consider the main function trigo is the cosine. So as we know, differential of cosine, you are going to get the sine with the angle star, and the differential of 4x minus pi over 2, we will get the value of 4. So therefore, the indefinite integral will become 3 over 4 sine 4x minus pi over 2 plus the constant c. Okay, example C, we have the two functions here. One is the cosine, the other one is the sine. So for the cosine, so as usual, you are going to get the sine angles, and the 3x here, if you differentiate, you will get 3. And the function sine here, we are going to get the minus cos. So therefore, for these cases, so the answer will be for the integral of the cos 3x, we get the sin 3x over 3 plus 3 sin x, so we're going to get a minus 3 cosine x plus 6. Okay, example D, so we have the function secant square and the cos. So as we know, the differential of the function secant square, we are going to get the tangent, and the cos, we are going to get the sine. So for here, we have to consider the differential of 3x to get 3. So pi, so for this case, the angle is alpha minus x over 2. So when we differentiate this with respect to x, we get the minus 1 over 2 here. So therefore, for these cases, so the integral of the secant square 3x, you get the tangent 3x over 3, okay, plus the tan sine alpha minus x over 2 plus the 6. So this one you will get this is because, so you're going to have the minus 5 sine alpha minus x over 2 divided by minus 1 over 2. So if you simplify the minus 5 divided by minus 5 over 2, so you will add minus 1 over 2, so you will get the value of tan here. The double angles formulas of cosines are going to be used whenever we are going to find the integrals involving the trigonometric functions of cosine square or sine square. Furthermore, so we are going to use the double angles of sines whenever we have the integrals of the functions of sines and cosines. Okay, let me explain to you through the following examples. So we look at the example A. So we're going to find the indefinite integrals of the trigo function sine square x. So I may choose to use the double angle of cos. So we have the cos 2a equivalent to 1 minus 2 sine square a. So therefore your sine square a will be 1. Is the 1 minus cos 2a divided by 2, and if I substitute my a with is x, so therefore, so I may rewrite the function sine square x in the term of the double angle. So you will have the 1 minus cos 2x over 2. So I try to expand first, then only I integrate. So I integrate 1, I will get x, and I integrate cos 2x, I will get sine 2x over 2 as this. Okay, I may leave the answers here or I may expand it up to you. Okay, so let's go through the second question, which involves the trigo functions of cos square through x. So again, so I apply the double angles of cosines. So cos 2a, so involve the term of cosine, so I will have the 2 cos square a minus 1. So therefore, my cos square a will be the 1 plus cos 2a over 2. So now let me substitute the angle a with 2x here. So I may rewrite the trigo function as the cos square 2x as the term of 1 plus cos 4x over 2. So I try to expand first before I integrate. So the integral of 1, so I will get x, and the integral of cos 4x, I will get the sin 4x over 4 as this. So you may leave the answer in this way, or you may choose to expand it. What I mean, I want to emphasize here is that, so please do remember to add the integral constant here, because this is the indefinite integrals. Okay, we proceed proceed with the example C. Here we have the function 2 sin square x minus 2 cos square x. So first of all, we may start to factorize with the minus 2. So we're going to have the cos square x minus sin square x. So I try to convert the trigo function cos square and sin square into term of double angle of cos to A equivalent to the cos square A minus sin square A. So if I substitute my A equivalent to x, so I may have the term of the cos square x minus sin square x of the functions cos 2x here. So and I start to integrate this, so I have the sin 2x over 2 and I simplify with the minus 2 here. So that's why I will have the minus sin 2x plus the c. Example D, I have the 6 sin 2x cos 2x. This seems like I can substitute with the double angle of sines. So if you still remember, so we have the sin 2a equivalent to 2 sin a cos a. So if I substitute my a with 2x, so that means this part I will have my sin 4x here. So therefore I may simplify as 3 sin 4x, then only I start to integrate my sines. I will get the minus cos and the differential of the 4x, here I will get the 4. So therefore I have the minus 3 over 4 cos 4x plus c. And finally is the example E here. So it seems like we have the angles of sines and cos. So I may apply the double angles here. So I put a value of 2 and I divided by 2, so this one so therefore I can apply my the double angle as this cos A. So I substitute my A with 3x, so this means that this part I will have my sin 6x here. So I have the 1 over 2 sin 6x. I convert this function in with the double angle. So now I have the single term of the trigo function. Only I start to integrate. So I integrate my sine. I have the minus cos and the differential of 6x is 6. So therefore I may simplify it as the minus 1 over 12 cos 6x plus c. As some of the integrals of the trigonometric functions, we need to use the compound angles formulas of sines and cosines, okay, to simplify it before we do the integrations. Let me explain to you through the following examples. Okay, look at the example 8. How are we going to apply the compound angles for sines and cosines to find the definite integrals for the following examples? So first of all, if we look at the question A, so we have the sines x cos x plus the sines 2x cos x. So we will apply the compound angle of sines A plus B. So let me substitute, the x equal to x and the b equal to 2x. So I have the sines A plus B. So A plus B, I will have the sines x plus 2x. So I have the sine 3x here. So I may simplify the trigonometric functions for this as the sine 3x. Then only I integrate. So the integral of sines, I will get the minus cos, and the differential of 3x, I will get 3. So definitely I will have the negative cos 3x divided by 3 plus the constancy. Okay, so the next example B, I have the sines 2x sines 3 3x here. So if I try to factorize with the minus 1, so I have the cos 3x minus the sin 2x sin 3x. So I multiply the compound angle of cos A plus B. So again, so I substitute my A with 2x here and my B with 3x. So definitely I have the cos A plus B is equivalent to cos 2x plus 3x. So I have the cos 5x here. So I substitute these trigo functions after cos 5x. So I have the minus integral of cos 5x and integral of cos. I will have the sine. Okay, and the differential of 5x I will get 5. So definitely for this question, the Lagrange integral of minus cos 5x, I have the minus sin 5x over 5 plus the constant C. Okay, student may do the following questions after formative assessments to evaluate whether you have cover the skills in doing the definite integrals of the trigonometry